Welcome to Summarize Science, where we dive into the latest breakthroughs changing our world. Today, we're looking at a massive leap forward in the world of 3D displays called holography. For years, holographic images have been held back by a grainy, noisy texture known as speckle. This speckle happens because the light waves interfere with each other in a messy, random way. To make a 3D image look real from many angles, researchers usually need to use random light patterns, but this is exactly what creates the noise. Current solutions usually require massive amounts of computer power or super-fast hardware to average out the noise over time. Now, a team has introduced a technique called ellipsography that solves this in a single shot. Instead of just controlling the timing or phase of light, they also manipulate its polarization. By shaping both phase and polarization together, they can cancel out the noise at its very source. This means they can keep the benefits of random light patterns without the annoying graininess. Their model uses something called Jones calculus to predict exactly how light behaves as a vector. This allows for deterministic control of interference at the optical level. To test this, the researchers built a prototype display using standard components found in many modern labs. They used two spatial light modulators and a half-wave plate to independently control different components of the light. They found that their single-frame reconstructions achieved the same quality as averaging 1 million traditional holograms. When comparing the data, ellipsography produces sharply peaked distributions that match the target image almost perfectly. Looking at the side-by-side comparisons, the difference in clarity is absolutely staggering. Older methods often look like they are covered in sand, whereas ellipsography looks smooth and sharp. One of the biggest wins here is how the 3D images handle depth and focus cues. The system can render sharp spatial details and natural defocus blur that is much more comfortable for the human eye. Usually, when you shift your focus or move your eye, a hologram might get blurry or distorted. Because this technique structures the light so precisely, the image stays high quality no matter where your eye is positioned in the viewing area. This is called pupil invariance, and it is essential for making a display that feels natural to use. In real-world tests on their prototype, the researchers saw a 10 decibel improvement over the previous best techniques. That is a massive jump in signal quality that finally brings holograms close to the detail we expect from modern monitors. So, let's recap why this is such a game-changer for the future. The researchers have broken a decades-old trade-off between image uniformity and visual noise. By using polarization as a control knob, they have made it possible to see crisp, 3D images without expensive, high-speed hardware. This technology could be the foundation for the next generation of augmented reality smart glasses. Imagine a future where your glasses project high-definition, 3D information right onto your field of view. This research brings us one step closer to making the sci-fi dream of perfect holography a reality. Thanks for watching Summarize Science, and stay tuned for more incredible tech discoveries.